Here we go. I'm also recording it for posting later, if that matters to any of you guys. So on 641, we've got subdividing a segment in a given ratio. We have actually already somewhat done this. It was just that we always used the same ratio, and that was 1:1 or a 1/2 segment. It's on 641. We found the midpoint when we were doing that. And so we just averaged the X's and averaged the Y's to find the point halfway between. So we divided it into a 1:1 ratio, meaning there was an equal amount on the left and an equal amount on the right. Well, this time we're doing the same idea, but it's not going to be 1/2 every time. And since it's not going to be 1/2 every time, that just changes our process a little bit. So in that process, what we're going to do, we're going to read this little first example right in here. We're going to circle or highlight or underline some stuff that's important to know. Now, keep in mind, this is just our first example, and it's working on a number line, which is just one direction. It's not X's and Y's. It would be just the X's. So on a straight highway, the exit for Arthur Avenue is at mile marker 14. The exit for Collingwood Road is at mile marker 44. The State Highway Administration plans to put an exit for Briar Street that is 2/3 of the distance from Arthur Avenue to Collingwood Road. Follow these steps to determine where the new exit should be placed. So we have 14, we have 44. We need to go 2/3 of the distance, and it tells us where to start. Arthur Avenue is where we start. Collingwood Road is where we end. Now, the starting and the ending point didn't matter last time because we were only going halfway, midpoint, halfway. But if you're not going exactly half, then the direction does matter. If you start in Jackson and then drive 20 minutes toward Dyersburg, you're going to be in a different place than if you start in Dyersburg and go 20 minutes toward Jackson. It's still going to be that no man's land out there between, like, you know, Bells and Alamo and all those places, but it's going to be a different spot. Same thing here. So we've got to know where our start is and where our end is. So that's all the information that you'll need to solve the problem. And step A just has us plotting those. So we're going to plot 14. There's 10, 11, 12, 13, 14. And it says to call that point A. And then point C was at 44. That was the Collingwood Road number. So 41, 2, 3, 4. And there's C. And what we're finding is B, which is 2/3 of the distance from A to C. So we're starting here and we're going this way. All right, so here's where we're going to start with our steps. So I'm going to write like the summarized version in caps, and then we're going to do the calculations kind of out to the side. So what is the distance from Arthur Avenue to Collingwood Road, and explain. To find that distance, we are going to subtract end minus start. It's always going to be end minus start. In some instances, when you find the distance or the difference between 2 points, it doesn't matter. But as we've already discussed, in this kind of problem, distance, the direction does matter. Because if I'm going 2/3 from here to there, it's going to be somewhere in here. But if I spin it around, puts it on the other end of the line. So order does matter here. Subtract end minus start. So we ended at 44. We started at 14. So how far was it? 30 miles. Got it. And now we're going to take that 30 miles and just move it to the next step. When I work these out, I just work them all in one long line. Okay. So you won't always be carrying it down and all of that. So the first step was to subtract, and that gave us the total distance. But we don't need to travel the entire distance. We only need 2/3. So we're going to multiply by the fraction needed. Multiply by the fraction needed. No, not always. I don't know. Asia, there should be a chat feature somewhere. So I'm not seeing it on mine, but I know it's in there. It's probably because I'm sharing a screen. So if you need me for anything, Asia, just like find that chat. It should pop up on my screen over here.
I'll let you know if I have questions.
Oh, perfect. Thank you.
Yes, ma'am.
All right. So then let me, can I put that back? I think I can just close that. Okay, good deal. So multiply by the fraction needed. So we needed 2/3, there it is. We needed 2/3 of that line. So instead of the whole 30, we need 2/3 of it, and that's going to be 20 miles. And again, I would just write this all in one big long line, but we're going to move down our 20 so that we can use it on our next step. So what we have figured out is that we need to move 20 units or 20 miles in this case from our starting place. So we're going to add the starting value. So our starting value on this number line, if we're starting at Arthur Avenue, is just 14. So where do we end up? 34. So we're going to find 30, 1, 2, 3, 4. And that's where B goes. And that's all you do every time. Subtract, multiply, add. And if you have like an XY ordered pair, you just do this once for the X's and once for the Y's. That's all it is every single time. So let's do a couple of examples. Flip the page. We're going to do example A, but we're not going to do it like they do it. They write a whole bunch. We don't need to do all that. So 642. Let me try to line this up a little better. Okay, now I know that a lot of people, not just students, not just you students, people in general, I can be guilty of this too, don't always read the directions. This is one of those sets of problems where you have to read the directions to get the correct order because the order matters. So in this case, you're going from A to B. That lets us know that A is the start and B is the end. And then you also notice we don't have a fraction here. We have a ratio. Ratios and fractions are very similar, but they're not always 100% interchangeable. So what this means, this 3-to-1 ratio, is I'm going to have 3 even segments before the point and 1 segment after the point. So how many segments do I have in all? 4. And I need to keep 3 of them. Now, the way you're going to do this every time is the bottom number is just the sum of these two added together. So 3-to-1, whatever those numbers are, you just add them up. 3 + 1 is 4. And then the top number is what goes on the top of your, the front number is what goes on the top of your fraction. So that'll save you from having to think it through like that every time. You just add up those two on the bottom, or add up those two and put it on the bottom, and then take the front number, put it on the top. Now, I go ahead and set up X's and Y's just like that. That way I kind of keep in line what I'm doing. If you want to, you can even go ahead and like circle your X's and underline your Y's, because it's real easy to jumble up your X's and Y's. Like working with 5 and -7 is what we're supposed to do, but it's real easy to work with like 5 and -8. It's just a simple mistake to make. So it's worth it to me to go ahead and put those little marks there to help keep myself organized. It's up to you whether you want to do that or not. It's an optional thing. So we're going to subtract our end, which is 8, minus our beginning, which is -8. So 8 minus -8. So that's a total of 16 spaces. Once again, we don't need all 16 spaces. We only need 3/4 of them. So we're going to multiply by 3/4, and that's going to give it. No, it's not. It's going to give us 12. I need to go 12 spaces. I need to go 12 spaces from the starting place. Starting place was -8. 12 plus -8 is 4. All right, now, check this out. You know, I'm a big fan of working smarter, not harder. If I have this line drawn for me, there's only one y value that goes with an x of 4. So I've already got my answer, really. I'm going to go find x is 4 and find where the line goes. That's my point right there. So the y value, you can just look it up. It's 2. I know it's on the first line, but it goes 2, 4, 6, 8. Right. So the point is 4, 2. That's working smarter, not harder. That's what you need to do on your IXLs. You don't have to do both points. But for the sake of practicing the calculation, we're going to go ahead and do the y's. We already know what it should come out to. So once again, the pattern is end minus beginning. So 5 minus -7. Tells us the whole line is 12 spaces. Multiply by the fraction of spaces that we need, and it comes out to 9. We need 9 of those spaces. And that needs to be tacked on to the front of the line, or the beginning point, which was -7. So add -7. And there's your 2. All right, let's look over on B. Same thing. Notice though the line is not drawn. Personally, I don't think it's worthwhile to draw the line. I feel like people are typically not accurate enough to draw their own line and then look up the y coordinate. Like, you got to be really, really careful to do that. So we're just going to calculate. So this is the same set of instructions, which said that A was our start and B was our end. And then what's this going to be as a fraction? Good, 1/3. So we're going to do our x's followed by our y's. End minus beginning. So 2, -4. So the x's are 6 units across. I don't need 6. I need 1/3 of that. So times 1/3. 1/3 came from right there. And 1/3 of 6 is, of course, 2. I know I need to move 2 places. So I'm going to go back to my start, which was -4. So 2 plus -4 is -2. That's where we're going to wind up. There's no line for us to just look up the y value, so we're going to calculate the y value instead. End minus beginning, 1 minus 4. Now, this is -3, but I don't want you to think that the line is -3 units long. This negative gives us direction. Okay, negative distances are not a thing, but when you're graphing, you can have a down direction, which is what this is. Negatives in the y value mean that you're going negative or going down 3 spaces. But I don't need all 3. I only need 1/3, so I multiply. So that means that I need to go down a total of 1 space from my starting place, and I started at 4. So I'm going to add 4. So your coordinates are -2, 3. All right, so we've done 2 examples with x's and y's. What questions do you have before we do the next couple? None? All right, then let's turn the page. We'll do just a couple more. Numbers 5 and 6. This will be it. I'll turn you loose to work. Hopefully you can get up to an 80 on that IXL by the time you leave. All right, so let's read the instructions because the direction is going to be given up there. From A to B. Now, it's not always going to be A to B. Okay, sometimes it's going to be B to A, or, you know, something else entirely. But you still always look to C. So A is our start, B is our end. The ratio is 5 to 3. What's the fraction? So you add up those two numbers, that gives you the 8. The 5 is just the top. All right, x's. What do I start with? Yes, it will end up being plus 6. You're going to subtract -6, n minus beginning, and then those two are going to cancel. So the whole line is 8 units long. Now what? Subtract, multiply, add. So what do I multiply by? 5/8. And that just gives me 5. So subtract, multiply, add. What do I add back? Not the 2. Good guess though. From the starting place, -6. There we go. So -1. And there's your x value. And if you had a line drawn like you will on IXL, you could just use that -1, plot your point, because it has to be on the line. But we don't have that line, so let's do some more practice with the y's. So it's subtract. What are we subtracting? Minus what? So that's going to be -8. And again, that doesn't mean the line is -8 distance. It means that it's down 8 spaces. And I don't need to go down all 8. What do we multiply by? The fraction 5/8, which is now -5. Plus, not -6. 5. Yeah, y value. So 0. So our final coordinates are what, comma what? Yep, there you go. You got questions? Okay. Well, I'll tell you what, let's go ahead and, let's see. Let's go ahead and look at your IXL for a second. I need to do a new screen share. Let's go here. All right, so in the IXL, I want to point out some differences. Asia, can you see that new IXL screen?
Yes, ma'am.
Okay, thank you. All right, so it says point P lies on NO. This tells you your direction of your line. N is the start, O is the end. And you'll have to look up your own coordinates, but I mean, they're on a graph, it's not bad. So it starts at 3:17 and it ends at 15:5. You just look them up, okay? You don't worry about all this. All this is saying is NP to OP is 5 to 1. Like, it's just putting point P in between N and O. Don't worry about it. You can totally ignore that part in the middle where it says NP and OP. All you need to know is the direction, which comes from this. And you need to know that this 5 to 1 needs to turn into a fraction, just like we had been doing. We add the two numbers together to get the bottom, and the front number becomes the top. So this fraction is 5/6. So I need 5/6 of this line. So I can do my x's. My x's would be 15 minus 3, so that's 12. And then in my calculator or on paper, do 12 times 5/6. So it's going to be 10. And then I'm going to go 10 spaces. And you could literally just count it or you could add it up. I'm going to start here and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces over. That's got to be my point because that's the only y value that goes with that x. 5/6 of the way, that's going to be most of the way. You know, 5/6, that's almost the entire way. It's not like 1/2 or something. So that's a good calculation, a good estimate. And that's all you do. Any questions on that? Okay, sometimes you graph it. Sometimes you do have to type the coordinates, like up in the higher levels, it has you type them. So you'll just do the same process that we've been doing all along. Yes, sir. Yep, sure can. Oop, probably not. You probably don't. I would recommend a lot of folks write them down. I think that's the place where I had this line. Hang on. This was 13. This was 3 and this was 13. Yeah, okay. All right, so another example. BC, this gives me the direction. B is my start, C is my end. And this fraction is going to become 4/7. So 4/7. Let me see if I can show 2 of these at one time. I'm getting fancy over here. Okay. So let's try this. Okay, right there. So B is at -4, -2. C is at 3, 5. This is my start. This is my end. And my fraction is 4/7. I took the 4 and 3 and added them together to get the 7. The 4 just stays on the top. So I'm going to do the same thing I've been doing. I'm going to subtract. Huh? How'd I get them? I just looked them up. These are the points. So here's -4. Here's -2. I just looked them up. And there's 3, 5 right there. So x's end minus start. 3 minus -4, 7. I need 4/7 of that. That's just 4 spaces. And so I started at -4, so I'm going to add -4, and that gives me 0. So my point's going to have to go right there. Wherever the x is 0 and that line crosses x equals 0, that's got to be it. Or you could calculate the other part as well. You would do end minus beginning, 5 minus -2, which is also 7, times the fraction that we need. And then I add back my starting y value, which was -2. And 4 plus -2 is 2. So my point should be 0, 2, which is exactly what I've got, 0, 2. Okay, do we need others? Okay, so get that up to an 80, and that should be it. Like, unless they tell us that we have to do something different tomorrow or have to make some kind of announcement, that will be the only assignment that you have for today and tomorrow. And my hope is that you would use that extra time to go back through missing assignments or low assignments and use that time to get caught up. So, excuse me. I'm going to be coming around passing out some like progress reports that folks were not here to get and different things like that. Please, please, please let me know if you have questions. And let me stop this screen share. And Asia, if you have questions, let me know. I probably just send a chat or something since my volume is going to be turned down. Yes, you can.